Good day, everyone. Welcome to the fourth lecture of this class entitled Quantitative Data Analysis Using Microsoft Excel. I am Dr. Nico Lawrence Losin, the course instructor of this class. When you are in high school or even in college, your teacher asks you to compute some statistics problem that are computed manually. In this session, you will be able to expose yourself in computing digital statistics problem using Microsoft Excel. So to start, I will be presenting an action research entitled Using YouTube Video in Teaching Grade 7 Science. And this research has the following research questions. What is the student's performance in the pre-test and post-test in grade 7 biology? Number two, what is the level of student engagement before and after the interventions? And number three, are there significant differences in the student's performance and student engagement before and after the intervention? So as you can see, the questions are arranged from descriptive questions up to the inferential statistics questions. So the first question can be answered using mean and standard deviation, same as number two, mean and standard deviation. Since they are ratio data or interval ratio data, we can interpret the results using the mean and standard deviation. And for the third questions, are there significant differences in the student performance and engagement after the intervention? It can be answered using this statistical tool. You can use t-test of independent means, paired t-test, or f-test. But we have to take note of the following assumptions in order for us to use the above mentioned statistical tests. Number one, we have to assume that the scores of the samples are in normal distribution, meaning to say once you graph the scores, they are distributed in a bell curve manner. And the second one, there is homogeneity of variance, and there is homogeneity of variance. Now, the third question is a type of inferential statistics wherein it tests the null hypothesis. I'd like to give emphasis that what we are testing is actually the null hypothesis, which means there is no significant difference. It is symbolizes with this representation, HO, or null hypothesis. So there are two ways to reject or accept the null hypothesis. We can use f-test. We can use f-test is f computed value is greater than the f critical value. If this is the case, we can reject the null hypothesis. Therefore, there is significant difference. Reject the null because the null is there is no significant difference. If we reject them, therefore, there is significant difference. Now, in modern publications, we are using p-value. In other research journals, they are combined. We are using f-test plus p-value. But in some journal, they are just using p-value. So if the p-value is less than 0.05, that's the time that you reject the null. Therefore, there is significant difference. So if the p-value is greater than 0.05, we can say that we can accept the null if it is greater than 0.05. Now, the p-value stands for the probability. So where it is rooted, so we have to bear in mind that 0.05 is a 5% of the p-value. So therefore, the 5%, it means that the 5% is the only thing that we leave to chances. So 95% that we are confident that our findings is correct or our finding has a probability to occur in a 95% level. Again, let me repeat the 5% or the P that is equal to 0.05, that is the 5%. That is the statistically significant or statistically acceptable value in order for us to accept or reject the null hypothesis. If we reject the zero point zero 0.05, therefore there is significant difference. So if we got a p-value that is 0.04, therefore we are 96% sure about our result. If we got 0.02, therefore we have 98% sure that our value or that our data is probably has a probability to happen. Now, what if we got 0.07? Well, therefore, we only have 93% sure that the event will happen or the probability that it will happen. So just reduce whatever you get, you compute it into percent value, and then you minus them into 100%. So if you got 0.09, therefore that is 91%. Okay. So for example, if there are two groups of students, you want to compare their pre-test and post-test, you can use paired t-test. So same as this, you can use paired t-test. What if you want to compare the pre-test or the post-test of the two? You have to use t-test for independent means. Same here, t-test for independent means. In other books, the paired t-test is also known as t-test for dependent means. Dependent means. Now, what if you have three groups to compare? For example, you are handling three classes and you want them to compare. So if you want to compare three values at a time or three sets of values at a time, you have to use F-test or analysis of variance. F-test or analysis of variance. Now, I'd like to, I want to be clear right now that the F-test is the name of statistical test, while ANOVA or analysis of variance is statistical procedure. Again, analysis of variance is our ANOVA is statistical procedure. You analyze the variance, while the F-test is the name that is a corresponding name for ANOVA. That's the F-test. Now, in order for us to maximize the use of this session, we will be having a workshop on quantitative-based analysis using MS Excel analysis toolpath. It is one of the underrated capacity of Excel. We only think that we can just use them for class record or for customer satisfaction or customer satisfaction survey or just sorting or tallying of data. But in this session, we will be maximizing its use through analysis toolpath. Now, here's the sample window that you can see on your screen. We have two sets of data as stated in the research question. You have your student performance, their pre-test and post-test, and student engagement, pre-test and post-test. Actually, there are 30 samples or 30 respondents from this study. We will just explore them later. Now, how are you going to activate your data analysis? So kindly check your data tab and then look if the data analysis is already available. Most of the MS Excel do not have this kind of features yet because it is an add-on. So if it is not yet available, I'd like you to click the File tab And then after clicking the File tab, I'd like you to click the Option tab or More Options, then Option tab. If you are using 2007 to 2015 version of MS Excel, I think there's only Option tab. Well, if you are using 2017 and above version of Excel, you can choose more options and then option tab. And then after that, this dialog box will appear. And then I'd like you to click the add-ins. Okay, and then after clicking the add-ins, I'd like you to click OK. So you will be able to see this. Uh, Manage Excel add-ins. This is the magnified version. Then I'd like you to click Go. After clicking Go, this dialog box will appear. Then I'd like you to check the Analysis Toolpack and Analysis Toolpack VBA. And then I'd like you to click OK. And then after that, I'd like you to check now again in your Data tab and kindly check if Data Analysis tool is already available. Now let me go back to this data. Now, as you remember, in this action research, there were three research questions that were asked. What is the student performance? What is the student's performance in the pre-test and post-test? And the second one, what is the student engagement in the pre-test and post-test? And the last one is, are there significant difference between their pre-test and post-test or after the intervention? So again, it was presented in the descriptive manner and then followed by inferential statistics questions. Okay, so I will be navigating through the available data using Excel. Okay, this is now the available data. Again, there are 30 respondents in this study examining their student performance and then student engagement. Okay, I'll be doing the student performance and I'd like you to do the student engagement during our asynchronous session. Okay, let's try it. Click data and then click data. And then this one is the tab for data analysis. A moment, please. Okay, this is now the dialog box. I'd like you to click first descriptive statistics and then okay. And then this dialog box will appear and then click summary statistics. And then in this tab, I'd like you to highlight this data. You can do it simultaneously for descriptive statistics. Highlight up to this part and then click OK. And there will be another sheet where you can see the results. So let's just magnify the columns. Okay, there you have it. The results for the 6. So the column 1, 3, and 5 contain the pre-test, while the column 2, 4, 6 contain the post-test. Column 1 and 2 for the group 1, column 3 and 4 for the group 2, column 5 and 6 for group number 3. So we will just extract two sets of data here that we highlight in the first slides, the mean scores, and then the standard deviations. In statistics, we are following the Eisenhower recommendation in which the mean score should only have two decimal place. So we will try to reduce their decimal place like that one. And then in standard deviation, we follow the Eisenhower recommendation, and they must be a three decimal place. Okay, there you have it. So you will just get the values of that. So this table is an example of statistical table. But if you are trying to publish the results of your data or you are presenting them in your chapter 4, it has to be presented in a presentation table. And presentation table look like this. Okay, this is the presentation table. You can see here that this is this is a table number, the title of the table, the group number, group 1, group 2, group 3, the number of respondents per group. There are 30, 30, 30 per group, total of 90. And then comparing their pre-test and post-test, the pre-test and the post-test. The one that you can see here in two decimal place, they are the mean scores, while the one that you can see in the parentheses are the standard deviations. In our previous discussion, we described that standard deviation, it has two functions. The first one, it determines close, how close or how far the scores are. And the second function, it determines the distance of the scores from the mean or how it deviates from the mean. Okay, that is how you get the standard. That's how you get the descriptive statistics using MS Excel data analysis. So imagine you did not compute, you just highlight some data. So imagine if you are handling thousands of data, it's hard to process, to compute, and analyze if you do that manually. But with the use of MS Excel, it's easy. Okay, so we have no answer for number 1 question. Now, for your activity, I'd like you to do the student engagement. Okay, I will be uploading the data, don't worry, in our Google Classroom or in our LMS, so you can work on the data. Let's now proceed to the third question, which is, are there significant difference in their student performance? To follow the same procedure, data tab. Then I'd like you to click this icon again for data analysis. And then this dialog box will appear. So click ANOVA single factor. Okay. This time we have to highlight the set of score that we will try to check if there are significant differences. So we have to do it manually this time by pair of the pre-test and post-test up to the last respondent. And then click OK. And another sheet or spreadsheet of data will come out. Let's just adjust the column. Now, in this result, there are only 3 cells that we need to pay attention. So this one, okay, okay. And early in our discussion, we can decide if we will accept or reject the null hypothesis if F value is greater than F critical or F crit, this one. So if that is the case, we can decide to reject the null hypothesis. Therefore, there is significant difference. Okay. The second basis, if the p-value is less than 0.05, we can reject the null hypothesis. Therefore, there is significant difference. Okay, there is a significant difference. Okay, same as this. Okay, so let's check. F value is greater than F critical. Therefore, we reject the null and there is a significant difference. P-value is lower than 0.05. We also need to reduce the number of decimal place into 3. So the answer is 0.12. Therefore, we can say that reject the null, there is a significant difference. So for conclusion, we can say that there is significant difference between the pre-test and post-test of group 1. We can say that they learn after the intervention. Okay, let's now proceed to group number 2 to check if there are also significant differences. So same, go to data, this icon for data analysis. But this time we will focus on group number 2. Same, we will still choose analysis of variance, but ANOVA single factor. We'll just wait for the dialog box to appear. Okay, single factor. And then let's remove the label, then highlight the sets of scores that we want to compare. Okay, and then okay. See, it's easy for you to compute, unlike if you will do or if you will perform the ANOVA test, it's quite long. Okay, so let's highlight the important details. Okay, or same observation. Let's just copy this. Okay, oops. Okay, let's check. F, F computed is greater than F critical, correct? So still reject the null. There is a significant difference. The p-value is 0.001. So that is less than 0.05. So there is actually in this case, there is a high significant, there is a highly significant difference, meaning to say the 0.001, the confidence interval of that is 99.9% sure that that event probably happens. Okay, let's go back to our previous data so we can get the uh, level of confidence. So call it as level of confidence. Okay, there's one. So 0.012. So we can say that it is 98.8% that the event will surely happen, that there is actually difference between their pre-test and post-test. So let's try number 3. Same procedure. Let's go to data tab. This one. And then this time we will highlight the group number 3 students' performance. In your activity later, I'd like you to do the student engagement part. Okay, you also need to highlight per pair. So you can check the student engagement from their pre-test and post-test. Okay, ANOVA single factor. Okay, let's highlight this one. Oops, let's delete first. Okay, highlight this one. Okay, let's adjust some columns. Okay, unfortunately, by merely looking at the results, okay, let's copy the basis. Okay, let's check. The F value is greater than F pre. No, this time. The F pre is higher than F value. Therefore, the answer is we have to accept the null and then there is no significant difference. Okay, p-value is less than 0.05. No, it's greater than 0.05. So you accept the null. There is no significant dip in this case. Let's revise this. You accept the null. There is no significant difference. Here, we have to change also the symbols. Okay, p-value is greater than 0.05 this time. So it is accept the null. And then there is no significant difference. So if the value is 0.955, so we can say that the level of confidence is just 4.55%. Sure that the result will actually yield uh, a correct decision. So to say that there is significant difference, it's just 4.55%. So see, that's too low. Okay? So that's how you compute for the F-test, and that's how you compute for the inferential statistics. So this table, again, is what's called statistical table. You do not post them in your chapter 4 or in your results and discussion. There is also a proper way for you to present your result, and here it is. So here is the table now for the difference on student performance in grade 7 biology pre-test and post-test. The group number, again, you need to indicate the pre-test, post-test, mean and standard deviations. Standard deviations are in the parentheses. You also need to include the F value, but no longer the F critical, it's just the F value. And then the P value and the remarks. Significant difference, highly significant, not significant. Which is how you post or how you present your data. You call it as presentation table. The one that is barely processed by the software, you call it statistical table, and you don't present that. You only present the presentation table. Okay, so in your task, I'd like you to work on student engagement and present them in statistic in presentation table. So here are the lists of statistical tool or statistical tests that you can also use. using the analysis of variance, using the data analysis tool pack rather. We have here Pearson R, Spearman rank, and chi-square test of independence. These are relationship, tests of relationship. This will be my topic next meeting. So used to determine the correlation or relationship between two variables, interval ratio. So for example, if you want to uh, test the relationship between the two, okay, for Spearman rank, also the same, but it's for ordinal. While for chi-square test, it's for nominal data. I'll go deeper for this topic next meeting. We will be talking about tests of relationship. Another test of difference that you can use if you have nominal data this time, z-test for independent proportion, while c-test for dependent proportion. This one, you are using independent proportion if the two independent groups, if there are two independent groups. So for example, the difference between, is there a significant difference between the male or female who are in favor of same-sex marriage? So male, female, how many males are in favor or against? And this one, female, in favor and against. So you can use that. So for dependent proportion, if the samples are the same or uh, there is a significant difference between pairs of observation from a single group. So for example, the decision of change of voters during election. What changes are driven after watching the meeting de avance. So before there are 6 who are in favor, while 30 who are against. So it's still 50. After the meeting de avance, 8 remains against, while the other is still in favor. The other one, from 30, no, no, no. From against, it become 4 and 16. If you get a total, you also get the same 50. So meaning to say, for independent proportion, independent samples, while for dependent proportion, paired samples. And you can also use chi-square test of goodness of fit. It is used if you want to compare significant difference between observed and expected distribution. This is the sample of chi-square table. 100 graduate students were asked about their opinion on the issue of Pacquiao's senatorial candidacy. Number who strongly agree, neutral, disagree, and strongly disagree. These are the total. This is the observed, the actual votes. This is expected. Okay, so there is a proper computation for that manually, but it can also be uh, compute using digital, but you have to use different software and it's not available in MS Excel data analysis. There is another app that you can use, the JASP. In statistical analysis, I'm using the software known as SPSS. But SPSS is a paid version of statistical tool. But JASP is a freeware, so you can use it. Okay, this is a sample. You can explore that. It's free. This is free and downloadable. This is how it shows its results. It is as good as SPSS, but the advantage of this, it is free. Okay, with that, that's all, and thank you very much for listening. Please work on your asynchronous tasks, which will be posted in your Google Classroom.